Lesson 7 of Chapter 1. We're moving right on through. Lesson 6 was just about scientific notation. So now that we're at Lesson 7, we need to do operations with scientific notation. So we need to talk first about multiplication and division. But before we get there, let's just do a little basic review. Every scientific notation looks like this. The first factor is a number between 1 and 10. Times 10 to an exponent. And that exponent, remember, tells you the number of spaces that were moved. But the big thing that you've got in this lesson is that this first one right here, that first factor, has to be a digit between 1 and 10. So let's talk about just the practice of the multiplication part. So whenever you've got two scientific notation numbers, you just multiply corresponding parts. So I'm going to multiply 7.2 times 1.6. Let's get our trusty calculator up here. Move it out of our way so we can see. 7.2 times 1.6 comes up to 11.52. 11.52. Now, if I'm multiplying these two corresponding parts, I want you to remember back to earlier in the chapter whenever we multiplied like bases. Whenever you multiply like bases, so it's 10 to the third times 10 to the fourth, you multiply like bases, you add exponents. So that would be 10 to the seventh. Now, that's all fine and dandy and easy as pie, but the problem is that it's not in proper scientific notation. Because if you remember, proper scientific notation has to be a number between 1 and 10, and ours is not. So if it's not between 1 and 10, we need to make it between 1 and 10. So the only way to make it between 1 and 10 is to move this decimal back right here. So it would be great if we could just move a decimal and move on, but you can't just move a decimal without also adjusting the exponent, because remember, that exponent stands for the number of spaces moved. So if it was originally 7, we moved it one more, which means it's either going to have to add 1 or subtract 1. So I want you to think that this was a number above 1, so it gets a number above 1 added to it. So it is 10 to the 8th. Let's try some down here together. Well, I guess you could try one on your own. Maybe try A on your own. Pause it. So for A, let's do this. 8.4 times 2.5. 8.4 times 2.5. 21. 21 times 10 to the multiply like bases. We add exponents. 2 plus 6, 8. This is not in scientific notation because it's not between 1 and 10, so we have to move it back 1. So we're going to put a 1 with this. 1 with this. This number was bigger than 1, so I'm going to put 1 bigger than 1 with it, so I'm going to add a positive 1 to it. My answer, well, let's just write it over here on the blank. 2.1 times 10 to the 9th. All right, moving this up, we're going to go ahead and just try B here together. So on B, 2.63 times 1.2. 2.63 times 1.2. I get 3.156. Oh, and glory be, look at that. It's already a number between 1 and 10. So we don't have to do anything to it. So this can stay just like it is. Now we just need to multiply our powers of 10, which means we need to add our exponents together. So we've got 4 and negative 3. Our signs are different, so we need to subtract and get 10 to the first power. And that is your answer. 3.156 times 10 to the first. So sometimes you will get lucky and get a number that's between 1 and 10 already. You don't have to do anything. If you get a number such as 21 or any number bigger than 10 or less than 1, you're going to have to do a little adjusting. Okay? So that was multiplying. Let's go down here. They actually give us a word problem to do division. I don't particularly care for the word problem they give us. I think it's a little confusing, but I do want to go through the procedure for dividing. Okay? So dividing kind of works like multiplying in that you do things to corresponding parts. All right? So you've got 7 and 3. That was our numbers, if I can move this out of the way here. I've got 6.86, what would that be? Million, billion, 6,860,000,000. That's the world population in 2010. The population in the United States was about 3 times 10 to the 8th. About how many times larger is the world population than the population of the United States? So they take, which is the reason why I don't really like this question, they take this and go ahead and take 6,860,000,000 and round it off to 7 billion, and 7 times 10 to the 9th. So anyway, I don't get caught up in the numbers of that. That's where all those come from. I'm focusing right now just on this part, okay? That's the reason why I didn't like the question, but we do need to go over the mechanics of it. So if you look, just forgetting about the whole word problem and just focusing on this part right here. Basically, you've got 7 times 10 to the 9th divided by 3 times 10 to the 8th, all right? So corresponding parts tells me I'm going to divide 7 divided by 3, 7 divided by 3, all right? I get 2.3 repeating, and actually that's what that little squiggly line right there means, is that it's about, it's not quite an equal, so it's at about 2.3 times 10 to the, now they take 10 to the 9th divided by 10 to the 8th. Remember that whenever you divide like bases, this is back from earlier lessons, when you divide like bases, you actually subtract your exponents. So you've got 9 minus 8. That's where they get their answer of 2.3 times 10 to the first. All right. Let's, actually, let me just make up one here for you. Let's try this. Let's try 8 times 10 to the 5th divided by 2 times 10 to the 3rd. So if I'm going to divide scientific notation, I'm going to divide these two numbers, 8 divided by 2, 4, times 10 to the, I need to divide these two, because they're like bases, I subtract the exponents, 4 times 10 to the 2nd. 4 times 10 to the 2nd. And this is proper scientific notation, because I have a number between 1 and 10. Okay, moving on. Let's go on to the next page. Go on to the next page. This example that's up there, the example that's up there, they've got 8 times 10 to the 4th, 8 times 10 to the 4th, 8 times 10 to the 4th, and then they've got 18,160. Now that written in scientific notation would be 1.816, 1.816 times 10 to the, and you'd have to move it, 1, 2, 3, 4. 8 times 10 to the 4th, or divided by 1.816 times 10 to the 4th. All right. So if I take 8 and divide it by my 1.816, it comes about 4.4. It comes about to 4.4. Come on. 4.4 times 10 to the, now I've got 10 to the 4th divided by 10 to the 4th, so I subtract my exponents, I get 0. Remember, anything times 10 to the 0 is just a 1. So that would be 4.4 times 1, which is just approximately 4.4. Actually, I probably would accept any of these, just not to be too particular. This is the preferred answer. All right, let's move on to addition and subtraction. Whenever I'm talking about addition and subtraction, again, I can only do like parts. I can only do like parts, and that's if they're written in like bases. So this number right here has a 10 to the 4th. This one has a 10 to the 5th. We can't do anything with that. They both need to be the same. So you could adjust this one to a 10 to the 5th by moving a decimal, or you could adjust this one to a 10 to the 4th and move the decimal. They chose to adjust and make it go down, right? So if this goes down one, this has to go to the right one. So now that I've got 10 to the 4ths, I can just add my numbers together. 92.4, 6.89. Remember, whenever it is decimals, we do have to line up our decimals. 9, 2, 9, 9. Bring decimals straight down. 99.29 times 10 to the 4th, okay? Now again, just like in multiplication and division, we have to make sure that that is in proper scientific notation. So now we're going to move our decimal back here. Because this was a number bigger than 1, I'm going to add a positive 1 to it. This is my answer, 9.929 times 10 to the 5th. All right, let's try another one here together. 7.83 times 10 to the 8th, 11,610,000. So if one of them's not in scientific notation, we do have to do that part of it first, okay? So actually your problem starts once after you get them both in scientific notation. Scientific notation is not equal because I've got 10 to the 8th and 10 to the 7th. So I need to make them equal, right? So it's easier, actually, if you'll just take and make one of them go down. So 10 to the 7th we're going to leave. 10 to the 8th we're going to make a 10 to the 7th. Remember, move it one place to the right to go down one. So 78.3 times 10 to the 7th. Minus 1.161 times 10 to the 7th, I can simply subtract my first numbers. And if I subtract them, I get 77.139 times 10 to the 7th. That last part hasn't changed. But now this is a number that's bigger than 10. So I do have to make an adjustment. Go back this way. This number was bigger than 1 to begin with, so I'm going to put a positive 1 with this. And that's how I get my final answer, 7.7139 times 10 to the 8th. Now, I understand moving all these decimals back and forth can be very, very confusing. So you may need to actually rewatch this part, maybe rewind it, watch them, try it again, okay? I just really, really want you guys to get that part. And it's jumped all, oh, come on. Really? Really? All right. We got to go way back up here. Way back up here. I guess this computer board doesn't really like this. It doesn't really like this either. All right. So I want you to go ahead and try got it. Just for time's sake, we're going to skip 5 and go ahead and try got it. Pause it, and then I'll give you some answers. Okay? Let's look at D. Let's look at D. 1.0551 times 10 to the 5th. For E, 1.24775 times 10 to the 9th. Well, they really got some long, ugly decimals up here in the front, but come on, make a 9, baby, make a 9. Okay. F, 3.33. Whoops, times 10 to the 6th. Okay? So make sure the keys on these were to make sure that we've got everything in the right power of 10. All right, let's try these last two here before we are done. Last two. Number 1, if I'm going to multiply 2.6 times 1.9, I get 4.94, already in scientific notation, times 10 to the 7th. These two, 8.37. 8.37 divided by 2.7, 3.1. 3.1 times 10 to the 5th. We do have to subtract those. Okay? Okay. So you can try the rest of these We will discuss them with you tomorrow.